ACERINOX was founded in 1970, becoming the first fully integrated stainless steel mill 15 years later. Located in Campo de Gibraltar, it has its own port and is situated in a prime location. We start from ferrous scrap as the main raw material, to which a certain amount of ferroalloys and other minerals is added. These materials have gone through a rigorous quality control process that ensures the safety and quality of the products manufactured. Stainless steel is an iron alloy with a chromium content higher than 10.5%. It is 100% recyclable and can be recycled as many times as required. Different grades are defined by their chemical composition and classified into 4 families: martensitic, duplex, ferritic, and austenitic. The production process starts with the selection and collection of the material to be melted. The melting shop is the first stage where scrap is melted in an electric arc furnace which has a capacity of more than 100 tons. There is a lot of flexibility when choosing the combination of raw materials to be used for each grade. Graphite electrodes make it possible to achieve temperatures of 1,600 degrees Celsius. At the end of this process, we obtain a primary composition that will go on to form the end product to be delivered. The molten steel is transported to the AOD or argon and oxygen decarburation converter in a transfer ladle. This phase starts with a blast of oxygen and inert gas and finishes with the refining of the alloy. The main process steps in the AOD are decarburation, where the carbon content of the melt is minimized. Reduction, recovering metal from the metallic oxides. And desulfurization, where the sulfur content is reduced. In the final stage, small additions of high-quality raw material can be made. During the process, samples are taken, and the chemical composition is analyzed in real time in the adjoining laboratory in order to fine-tune the elements to be added. The liquid steel from the AOD is decanted to the casting ladle and transferred to the tundish, a receptacle that facilitates the retention of slag particles that may be swept along with the hot metal and that prevents their presence in the ingot molds. The next step is the solidification process through the continuous casting machine, mainly in the form of slabs of up to 30 tons in weight. Once separated with a flame-cutting system and identified, some of the material obtained is ground with abrasive wheels and checked to ensure the surface quality of the products. This is the starting material for the next phase. Hot rolling begins with the entry of the slabs into the preheating furnace. The walking beam furnace is fueled by natural gas to optimize energy consumption. Residual heat is recovered in a steam-generating heat exchanger and used in our own factory to reduce the carbon dioxide footprint. The first stage of rolling is carried out in a reversing roughing mill. Starting from an initial thickness of 200 millimeters, a final thickness of 25 millimeters is obtained after several passes. During this process, steam jets are applied for descaling, and vertical lateral roll edgers act to ensure quality edges within the tolerance desired. The next step is the Steckel finishing mill process. This reversible mill has coil heaters on both sides. The strip temperature is maintained at high levels, which makes the process easier and avoids problems due to lack of ductility, especially in the thinnest gauges. After the finishing mill, water showers cool the strip in a controlled manner. The product range of thicknesses from 2 to 10 millimeters goes to a coiler and is extracted as black coil. Thicknesses ranging between 10 millimeters and 50.8 millimeters are shear cut at a high temperature, at lengths of up to 12 meters, and stacked for processing in the plates workshop. Plates are annealed and pickled individually. Dimensions can be adapted to the customer's requirements through a process of submerged plasma cutting. Black coil is the raw material used for the next phase in the cold rolling workshop. After hot rolling, the crystalline structure of the stainless steel has lost its metallurgical properties. The material therefore has to undergo a thermal regeneration process to recover these properties. To optimize the process and keep it stable, the furnace works continuously so that each coil is welded to the previous one. The annealing process is a high-temperature treatment followed by a controlled cooling. In order to obtain the appearance characteristic of stainless steel, it must undergo a pickling process. The surface quality is inspected by an automated high-precision system. Furthermore, at this stage, a rigorous dimensional control is applied to the material. The required final thickness is obtained using a Senzimir reversible rolling mill designed for rolling stainless steels up to 0.15 millimeters thick. The rolling stand consists of a set of 20 rolls. The work rolls, in direct contact with the strip, are changed several times during the process in order to ensure a uniform and high-quality finish. After the rolling process, the metallurgical structure has once again lost its properties and must go through an annealing treatment to recover them. While dull finishes pass through conventional annealing and pickling lines, bright finishes are processed in a controlled reducing atmosphere. The final appearance is obtained in a skin pass mill, which gives the surface its definitive properties. At this point, the metallurgical process has ended. Now the material is delivered to the cutting lines to adapt its size to our customers' needs. The coil may be cut longitudinally to give strips of any width, transversely for sheets, or in circles or flat bars. The material is inspected again. Samples are taken for the certification of their mechanical properties and corrosion resistance. ACERINOX's Research and Development Department works continuously using the latest technology to optimize processes and to develop new stainless steels that are more efficient and better adapted to the needs of our customers. The packaging of our products is designed to protect the material and to ensure that it arrives at its destination in optimum condition. Each format is treated individually, taking advantage of its geometry and taking into account the means of transport. The material, once packed, is ready to be delivered. Depending on the destination, it is sent by truck or ship, using our own port facilities. Hand in hand with progress towards better quality of life, ACERINOX.